Hey everyone, welcome back to the channel of Roller Coaster with Math. Today we are tackling an important concept in linear algebra, diagonalization. I'll show you how to determine if a matrix is diagonalizable, and if it is, how to find P and D such that A equals to P times D times P inverse. Let's now dive in. So first, what does it mean to diagonalize? Diagonalizing a matrix means rewriting it in the form A equals to P times D times P inverse. Now here, D is a diagonal matrix. P is an invertible matrix. P is an invertible matrix whose columns are the eigenvectors of A. But not every matrix can be diagonalized. First, we need to check if A is diagonalizable by ensuring it has enough linearly independent eigenvectors. So here's the problem we will solve. We have matrix A for 1, 0, and 3. We need to diagonalize the matrix A, and we will determine if it's diagonalizable, and if so, find P and D. Now let's get started. The eigenvalues of A come from solving the characteristic equation. So we need to find the characteristic equation to find the eigenvalues. So our characteristic equation for this matrix A is determinant of A minus lambda times identity matrix equals to 0. And first, we need to subtract lambda from the diagonal elements of A. Which is 4 minus lambda, and 1, and 0, and 3 minus lambda equals to 0. Sorry. Next, calculate the determinant. 4 minus lambda times 3 minus lambda minus 1 times 0. We'll get 4 minus lambda times 3 minus lambda. This term is 0. We cancel this. And we get a characteristic equation, which is 12 minus 7 lambda plus lambda square. And then we rearrange this equation, get lambda square minus 7 lambda plus 12 equals to 0. Now we have the quadratic equation. We factorize this quadratic equation to get lambda minus 4 times lambda minus 3. So our eigenvalues are lambda 1 equals to 4 and lambda 2 equals to 3. We solve the eigenvalues. Now we can find the eigenvectors. For each, we now find the eigenvectors for each eigenvalue. Remember, eigenvectors satisfy the equation A minus lambda times I, identity matrix times eigenvector V equals to 0. First, we find the eigenvector for lambda 1 equals to 4. We now substitute lambda equals to 4 into A minus lambda times I, A minus four times I equals to 4 minus 4, 1, 0, and 3 minus 4 equals to 0, 1, and 0, negative 1. Then we solve A minus 4I times V equals to 0. The first row gives 0 times x1 plus 1 times x2 equals to 0. So as you can see, x2 equals to 0. If we choose x1 equals to 1, free variable, then the eigenvector is v1 equals to 1, 0. Now we can find the eigenvector for lambda 2 equals to 3. we substitute lambda equals to 3 into a minus lambda times I. Then we have a minus 3I equals to 3. For minus 3, 1, 0, and 3 minus 3, then we get 1, 1, 0, and 0. We solve. Now a minus 3I v equals to 0. From the first row, we have 1 times x1 plus 1 times x2 equals to 0. So x2 equals to negative x1. We can choose x1 equals to 1 as the free variable. And the eigenvector now is v2 equals to 1, negative 1. Now that we have the eigenvectors and the eigenvalues, we can construct P and D. P, the columns are the eigenvectors v1 and v2. And D, the diagonal entries are the eigenvalues lambda 1 and lambda 2. So our P equals to 1, 1, 0, negative 1. And D is 4, 3, and the rest just 0. And that's it. The matrix A is diagonalizable. Now we can verify that A equals to P times D times P negative 1. We can verify this if this is true. So we have the matrix A, and we have the matrix A 4, 1, 0, 3, and the inverse of P equals to 1, 1, 0, negative 1 inverse, which equals to 1, 1. For P inverse, we have the equation determinant of P, D, negative B, and negative C, and A. So if we have a P equals to A, B, C, D, and then for our matrix P equals to 1, 1, 0, negative 1, we have the determinant of P equals to 1, negative 1, minus 0, 1 equals to negative 1. And now we can substitute into the formula. P negative 1 equals to 1 over negative 1, negative 1, negative 1, and 0, 1. Then we get a matrix for P inverse, which is negative 1, we get 1, 1, 0, negative 1. Okay. So now let's compute the P times D. P times D equals to 1, 1, 0, negative 1 times 4003, which equals to 1 times 4 plus 1 times 0, 1 times 0 plus 1 times 3, and this 0 times 4 plus negative 1 times 0, 0 times 0 plus negative 1 times 3. Then we have 4 and 3 and 0 and negative 3. Then we can compute the PDP inverse, which we now have a 4 times at the matrix 4, 3, 0, negative 3 times this P inverse, which is 1, 1, 0, negative 1. Then we have 4 times 1 plus 3 times 1 times 0, and then we have 4 times 1 plus 3 times negative 1, and then 0 times 1 plus negative 3 times 0, and then 0 times 1 plus negative 3 times negative 1. Then we have 4 . 1, 0, and 3. Which is our A. That's it. So we just diagonalized the matrix step by step. If you're enjoying this tutorial, give it a thumbs up, subscribe to the channel of Roller Coaster with Math, and let me know in the comments what math topic you'd like to learn next. Thanks for watching, and I'll see you in the next video.